All right, sleepy heads. What the? Okay, this one we're doing, we're factorising a trinomial. It's a trinomial because it's got three terms. M squared, negative 5m, positive 6. Cool, there are our three terms. Now, if you have a look at this rule bit up here in the box that I've already highlighted, you can see that we're going to end up with, when we factorise it back to a binomial, you've got the trinomial, which is in the form of something squared plus a plus b times something plus ab. Okay, they're your three bits. Cool? So what I'm going to do for this first one is I'm going to take it and I'm going to split it. I'm going to split this trinomial up into those three bits, just so we can see it and start getting an idea. That's where the p, the s and the f come from, the product, the sum and the factor. Okay? So if we have a look at this one, change colours to red. All right. The x squared part. Then there's the a plus b x part, and then the ab part. Does that make sense? I've just split up this bit in there, so I'm going to just write them down. I just want to split it up. You wouldn't normally do this, but I'm doing it for illustrative purposes. Yeah. Yeah, I'd write it down. Just so it's mainly so that you can just see where these bits are coming from. Just gives you, it's a sense of structure. The trinomial is structured in this particular fashion. There is this bit squared, there is this a plus b bit, and then there is the a times b bit. Cool? So, if we looked at the first part, so we're looking at pronumeral squared is what we're saying. Okay? So the pronumeral could be a y, which I did on the board a second ago. It could be a z. It could be an x. It could be an a or a b. What they're doing in this particular part is x is representing the pronumeral, a and b are representing numbers. Does that make sense? So in the factorised version, you've got x plus a number, x plus another number. Not necessarily the same number. So in this particular question, which bit is the x squared bit? M squared. That's why I was trying to explain it. Jess got it, but what I was saying is in this one here, which bit is the x squared bit? Now, which bit is the a plus b times x bit? Well done, you got the minus bit. Minus 5m. Yeah, negative 5m. Okay. And what is the AB bit? Okay. I'm going to put the positive in just so that we can see it for now. All right. So if you have a look at the bit in red, I've got an a plus b times x. Would you agree that that then means that a plus b has to equal minus 5? Having a look at this. In this particular case, a plus b has to equal minus 5, because I can just get rid of those bits for now. Yeah? Okay, so a plus b equals minus 5. And I'll actually put the therefore dots. Cool? Would you also agree on the next bit down that ab, or a times b, equals 6? I hope so, because that's what's written. Yeah? Okay. So can you see that we need to find, in order to answer this question, we need to find a and b. If we find a and b, we can then write that. Yeah? So when you think about it, the answer is actually going to look like this. It's going to look like a binomial product. Cool? And this m times m gives us that. So we've already got that bit. What we need is the a bit and the b bit. Yes, it does. Okay, so what we're looking for is we're looking for two numbers that do two things. Does that make sense? We're looking for two numbers that multiply together to give us 6 and also add together to give us minus 5. Okay? So we have to think of numbers that can multiply together to give us 6 and add together to give us minus 5. Cool? So, yeah, first thing we do is start thinking of the factors of 6. That's the easiest way to go, because there's lots of numbers that can add together to give you minus 5. I mean, 1 million and minus 1,000,005 add together to give you minus 5. But they don't multiply together to give you 6. So you're absolutely right. Start with the factors of 6. Okay, so 3 and 2. And I'll just put an F there, and that'll make more sense later on. I won't put F equals. I'll put F and I'll put a colon. So you know I'm not actually saying that F equals 3 and 2. Okay, now They have to multiply together to give you 6. They would do that, correct? But they have to add together to give you -5. So what do we do to them? Negative them. Make them negatives. -3 times -2 still gives you +6, because multiplying two negatives gives you a positive. And adding them together, you got -3 -2 gives you -5. Does that make sense? Now, does it matter which one's A and which one's B? Nah, not diddly squat. So we got -3, -2. That makes sense? Good. Now, they have written on the right in red, guess and check by trying -2 and -3, -1 and -6. Now, where did they get the -1 and -6 from? They are factors of 6 as well. Now, can you get -5 by having -1 and -6? Or can you have, -1 and 6? Or 1 and 6? God, stop talking, idiot. 1 and 6. Can you get to -5? You could have -6 plus 1, couldn't you? But the trouble is, when you multiply -6 and +1, you don't get +6, you get -6. Cool? But sometimes you have to try a couple of the factors to work out. 6 is a nice easy one because there's only 2 sets of factors. 1 and 6, 2 and 3. Cool? Other ones, you may have more than one set of factors. Make sense? Yes and no. There are clues that will make it a lot easier for you. I mean, if the number is 24, like the AB number, so this constant at the end is 24, then realistically you got 1 and 24, 2 and 12, 3 and 8, 4 and 6. So you're starting to get lots of numbers. But then you have a look and you go, well, what's that one? And you can start working it out. You can start narrowing it down. If it's not 23 or 25, then you know it's not 1 and 24. Okay? Yes, you may. Yeah. You don't get why the x is there. Okay, when you actually do this, you do, so if I've got x plus a, x plus b, which is what we just got, right? That's the answer we got. If I do first by first, I get my x squared. If I do my outer by outer, I get plus bx. Then I do my inner by inner, I get plus ax. Then my last by last is plus ab, yeah? But I can take that bit and pull out a common factor. What's the common factor? Cool. So I end up with x outside of b plus a, which I can rearrange to be a plus b outside of x. Does that make sense? Yeah. So it's just when you expand the binomial expansion, I could have the x in front, yeah. Yeah, over here I could have the x there because it's commutative, so x times this is the same as this times x. 2 times 3 is the same as 3 times 2. Okay, that's commutative. Cool? Awesome. All right, scroll down to the next one. So the next one, we're going to do the same thing. Now, it's got guess and check. I'm trying to get you guys away from guess and check pretty early in the piece. Okay? I don't want you to guess. I want you to use the information that's given in the question. Okay? So before we even start looking at products, sums, factors, anything like that, what I want you to have a look at is that bit at the end, the constant at the end. What is it? -2. So you know that that's going to be a times b. You know, when you've done your brackets, you're going to have the a and the b at the end of the brackets. You've got the pronumeral at the front of the brackets. You know that a times b is -2. That should immediately tell you something about the number. The numbers, sorry. Don't tell me what the numbers are. So ask for something about the numbers. Your answer is -2. You've multiplied two numbers together and you got -2. Multiply two negatives together, you get a? Cool. So you know, or multiply two positives together, what do you get? Positive. So to multiply together to get a negative, you have to have a negative and a positive. So you're already on the right track. You're already starting to think about it. Okay? So you know you need a negative and a positive. Okay? Now, the other thing is you've got a positive in front of the y. You've got a positive 1. Okay? Now, you've got a negative number and a positive number. You know that because they have to multiply together to give you a negative. You have a negative number and a positive number. Well, we don't know. We don't know what y equals. We don't care. But there's a 1 in front of that y that we just don't write. So that's our a plus b. A plus b equals 1. It equals positive 1. Now, you know that those two numbers that you worked out for this bit have to add up to 1. Okay? But you know that one of them has to be a negative. So it should make sense that if you're adding two numbers together and getting a positive answer, then the biggest one of them has to be positive. Otherwise, you'd be still in the negatives. Make a bit of sense? It'll make more sense once we actually do this. So we're actually going to use the product, sum, and factor method of doing this so that you can see what we're going on about. So we've only got 4 minutes before the thing runs out, so we'll do it quickly. What does the product have to be? Okay, so this is where it's getting a bit confusing. Ow, that hurt my neck. All right. That's the product. Which one is the AB part? -2. So our product has to be -2. Does that make sense? Yeah. On the previous one, it was 6 or whatever it was, yeah? Now, the A plus B part is the sum. What does our sum have to be? 1. Because that's the number in front of the y. That's the coefficient in front of the y. So our sum has to be 1. And I'll put a positive in front just so we're not getting confused. Cool? So we need two numbers. The product is -2 and sum is 1. So the next bit we do is we put a little F for factors. Well, the first thing I generally do is I write down the groups of factors. Okay, if it was 24, I would do 1 and 24 and so on and so forth. This one, what are my factors? 1 and 2. They're my only factors, right? Now, on the red bit here, it says guess and check by trying 2 and -1 or -2 and 1. I'd prefer that you looked at it and go, well, for me to get a positive number, this can't be negative. Because if that's negative, I add 1 to it, I'm still going to be in the negatives. Does that make sense? So what I'd like you to do is look at it and go, well, this is a negative where you're multiplying, so 1 has to be positive, 1 has to be negative. This is a positive, the biggest one has to be positive. Simple as that. Otherwise, you'd still be in the negatives. So which one has to be positive? The 2. And which one has to be negative? 2 times -1 will give you -2. 2 minus 1 gives you 1. You're done. So now you can write it down. What's it going to look like? Spot on. That's it. Does that make sense? I hesitate to let you guess and check because it can be not as useful as it seems at first. Oh, I'll just guess and check. I don't need to remember. It's easier if you remember the little tricks. Yes, because they want me to let you guess and check.